In this video, we're going to explore how we can start with acetic acid, and acetic acid looks like this. How we can start with acetic acid and end up with acetyl chloride. Acetyl chloride that looks like this. And it's going to be done in the presence of thionyl chloride. And thionyl chloride, we haven't seen it before, but it just looks like this. It's a sulfur double bonded to an oxygen, and then it has single bonds to two separate chlorines. And then if you want to care, sulfur has 6 valence electrons, so it has another lone pair right over here. And we'll focus on this because this is really the simplest reaction of starting with the carboxylic acid and forming an acyl halide. And it can be generalized very easily if you turn this methyl group into just a larger chain, and then this will be a larger chain right here. And instead of having a chlorine here, you could do it with other halides as well. So let's think about how this might occur. So let's have our acetic acid right over here. So acetic acid right over here. And then you have this oxygen bonded to a hydrogen, just like that. Now this guy's got 2 lone pairs. And then the thionyl chloride, I'll redraw the thionyl chloride right over here. The thionyl chloride, and I'll set it up in the right position. The thionyl chloride looks like this, and this has a lone pair of electrons right over here. And all of these molecules, chlorine and oxygen, or all of these atoms, chlorine and oxygen, we can look at a periodic table up here. You see sulfur over here, and then to the right of sulfur is chlorine, and above sulfur is oxygen. So both chlorine and oxygen are more electronegative than sulfur. So sulfur is going to have a partial positive charge there, even though sulfur is a reasonably electronegative atom in its own right. But these other guys are going to be sucking electrons away from it. So you could imagine that this oxygen could act as, or this entire molecule could act as a nucleophile, with this oxygen right over here giving an electron to the sulfur. Sulfur is an electronegative atom, but it has a partial positive charge in just this thionyl chloride. So it'll be attracted there, and then this guy's going to have to give up an electron, and he'll give it back to this oxygen up there. And so that will be, and this reaction can go in either direction. So once again, I'll draw it in equilibrium. But right after that happens, we'll have this, I guess we could call it a complex that would look like this. This oxygen, it had 2 lone pairs. It had 1 pair, 2 pairs, and now it has a third pair because it got this electron. It always had that other electron in the covalent bond. And now it has a negative charge. And now the sulfur is bonded to those 2 chlorines. And then it is also bonded to this oxygen over here. So let me draw it over here. So we have this oxygen, which is bonded to this carbonyl carbon, just like that. And then it is bonded to a hydrogen right over there. It has 1 lone pair now, and then the other lone pair is now turned into a covalent bond with the sulfur. And so this guy gave away an electron, so he now has a positive charge. Now the next step, you could imagine that this oxygen says, hey, I liked having a double bond with the sulfur. The sulfur is still bonded to a bunch of things that are more electronegative to it. It still has a slightly positive charge there. So you could imagine that this electron gets given back to the sulfur, but then the sulfur needs to bump an electron. Chlorine is pretty electronegative, so the chlorine can take one of these chlorines will be able to take away an electron. So this chlorine could take away an electron. So then after that happens, our situation, and once again, this is in equilibrium, our situation will look like this. Let me draw. So let me draw the original acetic acid, or the part that was part of the original acetic acid. And so you have this oxygen right over here, bonded to a hydrogen, bonded to, let me do it in the same color so we can keep track of things, bonded to this sulfur right over here, which now has a double bond, which now again has a double bond with this oxygen up here. So I'll do it in that same color. It's still bonded to that chlorine up there. Still bonded to that chlorine up over there. But now this chlorine is left. It's taken that electron with it. So the chlorine had 1, 2, 3, 4, 5, 6, 7 valence electrons. It gained this electron, this orange electron. So now it has a negative charge. And by the way, this guy never lost his positive charge. Still has a positive charge right like that. Now, the chlorine could act as a nucleophile on the carbonyl carbon. This guy is bonded to two oxygens, more electronegative, slightly or partially positive charge. This guy can give an electron to the carbonyl carbon. And right as that happens, this is a nucleophilic attack. Right as that happens, the carbonyl carbon can give up an electron to the carbonyl oxygen. And then we will be in equilibrium. We will be in equilibrium. So make sure you realize we're going to the right, then down. Now we're going to the left with this thing. So you have, this was the carbonyl oxygen, carbonyl carbon bonded to this oxygen right now, which now just took another electron. So now it has a negative charge. It had 1, 2 lone pairs. Now it will have one more lone pair because it took that electron. It always had this end of that bond. So now it has both of these electrons over here. It has a negative charge. It gained an electron. And then it is bonded to this OH group right over here. This OH group, just like that. And then that is bonded to the sulfur. That is bonded to the sulfur, which is bonded to the chlorine, and now double bonded to that other oxygen. And now double bonded to that other oxygen. Of course, we have this chlorine over here that did the nucleophilic attack. So you have this chlorine over here. And this nucleophilic attack, it gave an electron to what was this carbonyl carbon. It gave an electron, so it is now neutral. And you can kind of imagine that this negative charge got transferred to this oxygen up here. And this oxygen right here still has a positive charge. Don't want to forget that. Now, the next step that could happen, once again, all of these can go in either direction, is that this guy doesn't like having a negative charge. And this guy is still going to have a partially positive charge because he's bonded to a bunch of more electronegative atoms than itself. So he wants to reform the double bond, reforms the double bond, and that kicks off all of this business over here. So then this, let me do this in a new color. I've already used the magenta. I'll use the pink. This electron right here gets taken back by this oxygen that had a positive charge anyway, so it would want to take it back. And then we are left with, and this is we're getting pretty close to the punchline. We are then in equilibrium. This part over here will then look like this. We now have reformed our double bond. It is only going to be bonded to the chlorine, just like this. And this whole part over here on the right has broken off. So you have this oxygen bonded. Let me do it in the same colors. You have this oxygen bonded to a hydrogen. It now gained an electron. So it is now neutral. And it is bonded to this sulfur. The sulfur is in green. It's bonded to the sulfur, which is bonded to a chlorine, which has and then it has a double bond to this oxygen right over here. So we formed our acetyl chloride. We formed our acetyl chloride. And we've really kind of finished with the hard part of the reaction to see that how you could get an acetyl chloride. And then to kind of complete this reaction, because if you actually perform this in a beaker, you'll end up with some hydrogen chloride and some sulfur oxide as a byproduct. You could imagine that this oxygen right over here takes back its electron from this proton, gives it to this sulfur, and then the sulfur, since it got an electron, will allow the electronegative chlorine to take back its electron. And then if we just focus on this, the acetyl chloride at this point isn't doing anything anymore. This would be in equilibrium. This would be in equilibrium with something that looks like this. You now have a hydrogen proton floating around. You now have this hydrogen proton floating around, just a naked proton, really. There's not even any neutrons there. You have this oxygen, which is now double bonded. It is now double bonded with this sulfur. So I'm going to try to keep all of the colors the same. This right here was yellow, and then that original bond that it had with it was magenta. And then you have the chlorine nabbed that electron. The chlorine, I'll do this chlorine in blue now. The chlorine nabbed an electron, and it already had 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. It now has a negative charge. And then the final step, so we already have our sulfur dioxide. Now the final step is just the chlorine giving one of its electrons to the hydrogen to form hydrogen chloride. So then the final step is just this. And then we end up with, so when all is said and done, we end up with some acetyl chloride. We end up with some acetyl chloride. We end up with some hydrogen chloride. We end up with some hydrogen chloride. And we end up with some sulfur dioxide. Sulfur dioxide. Just like that. And we're done. And once again, you can generalize this to get it starting with any carboxylic acid and forming the acyl halide version of it, or the acyl chloride version if you want to stick with a chloride right over here. Oh, actually, this right here is acetyl. This is acetyl chloride. Anyway, hopefully you found that entertaining.